Okay, that's a terrible X and Y axis, but it's going to work for us today. All right, guys. So we are graphing exponentials to begin with, okay? With your exponential, every time, hey guys, up here. You're going to start with a point 0, 1, and then 1, whatever your base is. So I'm just pretending on this parent graph here. And then the shape of your graph looks like that. 1 base, yes. That's what you always start with as sort of your parent graph, and then we're going to do all of the transformations with that. Okay? Those are the only 2 points you have to graph for me, assuming you can draw your shape appropriately from there, okay? Do we have an asymptote in this one?
Yes.
Yes. Horizontal, very good. We have a horizontal asymptote at 0. So that is our asymptote, okay? All right, let's look at our interesting facts over here. What's your domain of an exponential graph? What about the range? Infinity. How many x-intercepts are there? 0. Yeah, none. And your y-intercept is always good. Y equals 0. That's a horizontal asymptote. And it's only as x approaches which direction? Negative infinity, good. So it is still a horizontal asymptote, it just only tells us about the left end behavior of our
Class of the parent function.
Yes, before any shifts, anything like that happen.
Are we going to need to know E again?
You're just going to have to show me 2 points and then, I mean, you're going to have to understand what the shift is doing, but. So you're always going to start with 0, 1 and 1 base as the 2 points in your graph. And then we can apply our transformations to that. And then your graph will always be smooth and continuous. Okay. All right, is that all fairly familiar to you guys? Yes? Okay, let's try to graph some. So I know I'm skipping over this little middle part because we're just going to do it instead of talking about it. All right, so let's do number 1. My graphs look terrible. Yours, I know, are just really small. I'm going to try to draw in my x and y axis at least here. Okay. All right, so let's walk through this first one together. I need to start with the point 0, 1, so I can plot that. And then 1 base. Well, what's my base this time? 2. Good. So I start with the point 1, 2. Okay, so we've got a couple of different transformations happening here. We have that 3 out in front. What does that do? Stretches vertically, horizontally. Vertical stretch by 3, and then we've got a couple of shifts, right? We're going right 1 and down 4. Okay. It's like order of operations. You should multiply before you add or subtract. Okay, so do your stretch by 3 first. If it's a vertical stretch, do you think that's changing your x or your y value? Y. So just take your 2 y values and multiply them by 3. Okay? So instead of 0, 1, I'm going to have 0, 3. And instead of 1, 2, I'm going to have 1, 6. Okay? Then we can shift those points. So each of those points, the blue ones, I'm going to move mine to the right one and down 4. So right one, down 4, right one, down 4. Before we sketch the graph, we need our asymptote. Did my asymptote move?
Yes.
Yes. Where did it go? It went down. It went down more than
-4.
Yes. Think about your vertical shift. That's the only thing that's going to change a horizontal asymptote is moving it up or down. How far down did we shift? 4. So your asymptote is all the way down there at -4. So 1, 2, 3. I don't have lines on mine. We'll pretend it's right there. Then you can draw the shape of your graph. I missed a point. Hopefully you draw better than I drew. So as long as it approaches your asymptote, correct general shape, and you've moved those 2 points appropriately, that's all I need to see on your graph. Okay? So multiply it first, then do your shifting. So let's look at number 2 together. What are the 2 points I'm going to start with on this one?
0, 1, and 1, 3.
0, 1, and 1, 3. Maybe I need an X and Y axis. 0, 1, 1, 3. All right, do I deal with the -2 or the +2 first? -2. So that's a stretch and a flip, but if you just multiply your Y values by -2, you're taking care of both of those in one step. So instead of 0, 1, I would have 0, -2. And instead of 1, 3, I'm going to have 1, -6. Okay, where do I go? Left 2. All right, we did a lot of things, but did we do anything that's going to change our asymptote? No, so it is still at 0. And then just sketch your shape. So remember, you flipped it upside down. So there is your shape of your graph. Make sense? Okay, you guys try 3 and 4. I realize I'm giving you the 2 with fractions as basis, but that's okay, you can do it. Confident. Doing it all at once. Stop doing that. If you're not and you can just see it, that's fine too. You don't have to show me all the dots along the way. But don't mess it up if you don't show me all the dots. horizontal. You guys got them? All right, guys, let's look at the first one here. Your two initial points are 0, 1, and then 1, 1/2. So this is not exponential growth, is it? Like if you were to actually graph that parent function, it'd be decreasing as you approach the infinity. So keep that shape in mind as you go through it. Multiplying by -3. So instead of 0, 1, I get 0, -3. 1, 1/2 gives me 1, -3/2. Then I have to go left 2 and up 1. So, 2. What about your horizontal asymptote? Where is it on this one?
Y equals 1.
1. Good. Y equals 1. With that, you can then sketch your shape. Okay. If you're struggling with how to draw it with just your 2 points at the end because you're not sure if it was decay, what's going on, make yourself a little sketch of the original and go, okay, I know that's what was happening. If I flip that over the x-axis, that's the general shape of what should be happening. Think through those basic transformations that you need to. How do we do on 3? Making sense? Okay. All right, let's try 4. So your points this time were 0, 1, 1, 1/3. Then we need to multiply by 2, so I'm going to get 0, 2, 1, 2/3, which really 1/3 and 2/3 on this teeny tiny graph. Not much is happening there, okay? And then all I'm doing is shifting down 2. Down 2. And what about my asymptote?
Negative.
Yeah, y equals -2. And then I can sketch the shape. Okay? Yes? Okay. Let's jump in your notes to the graphing of logs because it's directly tied to the graphing of your exponentials. And then we'll come back to the solving and converting, all of that stuff. So find for me this page. You hate logs? You don't really hate logs, do you? You're not that beautiful. You really hate logs. I think it'll be better, okay? All right. I am going to grab what we wrote from the last one, the parent graph here we did, f of x equals a to the x. Oops. Remember that was 0, 1, 1 base, looks something like that, right? How are logs and exponentials related? You guys remember?
Obviously, inverse of
Yes, they are inverses of each other, okay? So what do you remember about inverses?
the X and the Y.
X and Y get switched, yes. So if X and Y are switched, what do you think would happen to their domain and range?
Switch.
Yeah, they're just switched, okay? Graphically, what happens? What does it get reflected over?
The X and Y equals the X.
Yeah, it gets flipped over this different color, right? Reflected over that. So instead of 0, 1, I would have 1, 0. And instead of 1 base, I'm going to have base 1. So you guys see how that's a reflection? With my imperfect graphing abilities, but you can see that it's reflected. So instead of a horizontal asymptote, what kind of asymptote do you think we're going to have? Vertical, yeah, okay. So let's fill all of that into our interesting facts over here. So domain is the range that we just did for the exponential. So what is the domain here? 0 to infinity. The range of your log would be like the domain of your exponential. So what's that going to be? Yeah, and you can see it from the graph too. Does that make sense to you guys? Do you see how those two are just flipped from your other one? And this time, instead of not having any x-intercepts, we don't have any y-intercepts. So there are 0 y-intercepts. And your x-intercept will always start as 1, 0. Instead of a horizontal asymptote, we have a vertical asymptote. And our points this time are 1, 0 and base 1.
What's the base in that graph?
I just pretended it was 2, but it's A, technically, with how it's written. And still, our graph is smooth and continuous. Okay? Makes sense how they're connected? The process for graphing is exactly like what we just did for exponentials. So you're going to start with your 2 points, and you're just going to do all the transformations from there, and that's it. So there's no like plugging things in and evaluating them with a log. You don't have to do it. You can just find your 2 points, use what you know about graphing from everything else, and make your graph. Let's do one together. So hopefully I can get some sort of x and y axis here. All right, so the initial points that I start with, what are they going to be this time? 1, 0, and 3, 1. Excellent. 1, 0, and 3, 1. All right, and where is this graph going? Right 1, down 4. So right 1, and I'm counting into blank space for mine. Hopefully you have lines somewhere. So 1, 2, 3, 4, sure. Right 1. Something like that. All right, what kind of asymptote do I have? X equals, and it's been shifted to the right. So yeah, it's at x equals 1. It's okay. Once you have that, you can go ahead and sketch the shape of your graph. Make sense? Okay. Try the next 3 for me. Do 2, 3, and 4. guys, let's make that last one a little trickier. Let's put a -2 in front of it. So -2 log base 2 of x plus 2 minus 1. Oh geez, that's lunch, okay. All right, we'll finish after lunch, guys. Grab one of those passes, All right, guys, let's take a look. I'm guessing you were probably fine with 2 and 3. Realize that 1 out in front and 3 is a vertical shift up. 4 is the tricky one because I put the -2 out in front there. Questions? What do you need me to walk you through? 4, okay. So are we okay with our first 2 points of 1, 0 and 2, 1? Yes. Okay, the 2 red dots. Which that one good. I have a -2 in front. I have to deal with that before I do any of the shifting. What does a -2 do to my graph? Flips it and stretches it vertically, right? It's out in front. So you're taking these 2 y values and multiplying them by -2. Well, -2 times 0 is still 0. -2 times 1 becomes -2. Okay? So now I've got these blue dots. With those, I'm shifting them each left 2, down 1. So left 2, and I'm off because I don't have lines on here. Left 2, down 1. This one should have been up a little higher. Might make it easier to see. Left 2, really it's more like that. I'll make my dot big enough and then you'll see it. Your vertical asymptote, the only thing that happens is it goes left 2. Okay? How'd we do? Okay, yes. so you're good? Okay. Anybody questions on graphing? All right, so let's go back and look at some of these other solving pieces. So solving exponential equations. So we're jumping back. This was below the graphing exponentials. Sorry to make you jump around a little here. All right, when we have an exponential equation, you want to make the bases match on both sides of your equation if you can. If you can't, then you're going to have to involve logs in some way. But for right now, I can make my bases match, right? So what base do you think I want to use on number 1? 3, yes. So I'm going to have 3 to the x plus 1 equals 3 to the 4th. Now, since the bases matched, what must be true about my exponents? Yeah, they have to equal each other. So we just have the simple equation of x plus 1 equals 4. Not too bad. So x equals 3. Okay. All right. Do 3 and 4 and try 2 last. 2's the hardest, okay? You have to remember all your exponent rules for number 2. So try 3 and 4 first and then come back to that one.
Zero squared is 0. 0 is 0. Makes that 1. 1 squared.
Yes, that's good. Now you just have to solve the factor. Number 2, you're going to have to either complete the square or use the quadratic formula, something at the end. Oh. Oh, keep getting more. That's good. I was so confused. I was like, I want to know how cold it is. Do I have one? I've been off for a while. The air that's coming out is Yesterday I couldn't find. No, I shut it off. Second two. No. Good. Yeah, I grabbed one of the passes. All right, let's look at them, guys. I'll work my way back to 2. So number 4, are we okay with matching our bases? And then reminder of your exponent rules. When you have a power to a power, what do you do with them? Multiply. Power to a power. If you're multiplying, you add. Power to a power, you multiply. So this is really 3 to the 4x. And this is 3 to the 3rd. So did you guys get 3/4? Yes, we're okay with that? Okay. This one, move the 2, not 4x, 2x. Move the 2 to the x over. Set your exponents equal, and we just get x equals 0 for that one. Fine there? Okay, now the exciting one. Maybe exciting isn't the right word. But so power to a power, e to the x squared. What is that? Yeah, so it's just e to the 2x. It's not e to the x squared, okay? And then 1 over e, isn't that just e to the -1? Okay, same base, so I know I can add my exponents. So I really have e to the 2x minus 1 over here. Bases are the same, so -x squared equals 2x minus 1. 0 equals x squared plus 2x minus 1. If you want to complete the square, move the 1 over. And then I'm adding 1 to both sides. So -1 plus or minus √2. Yes. You okay with that? No? Okay. Questions on any of those 4? The second one, definitely the trickiest. It's all about your exponent rules, so don't be scared because there's an e, that's just a number. All right, and then just think about your laws of exponents. I know I completed the square very quickly, but are you guys we're getting better at completing the square? It will show up again. I will just randomly ask you to complete the square on a quiz or a test at some point. Can you do it? Yes, okay. All right, let's keep going. Our time is disappearing today. Okay, E, the number E, you're going to learn exactly where it comes from later in the year, but for right now, you just need to know it's an irrational number, kind of like pi, but it's 2.718, that's your approximation there. And we use E as a base for natural log. So anytime its base is E, you know you're talking about a natural log. What we're going to do is rewrite some of these as exponential equations. There's 2 ways you can do this. You guys were probably pretty good at it in Algebra 2, being able to go 7 squared equals 49, like recognizing what's the base, what's the exponent. Another way to do it is what's called to exponentiate both sides of your equation. So I could take the base and then raise it on both sides. That's exponentiating. This ends up just being 49 equals 7 squared. But I think most of you are probably okay just writing 10 cubed equals 1,000. Am I right? Okay. So number 3, what's the base on that one? E. So we'd have e squared equals e squared, if you were just rewriting it exponentially. What about the last one? What would you write for 4? Okay. So we're okay with that, right? Okay, we're not going to do all of them in the next section. We're just going to pick a few. So number 1 there, if I wanted to rewrite that as an exponential equation, what would it be? 5 squared equals x. So then 25 is my x. Okay. What about, let's look at number 3. How would I rewrite that one? Okay. When you solve that, you'd normally tell me that a equals plus or minus 4, right? Do you think both of those solutions are okay? No. You're like, well, you're asking, so probably not. Okay, they're not. Why is negative 4 not okay? So you can't have, well, not negative 4. You can't have a base that is negative like that. So do you see how a is the base of our log? You're never going to have a negative base down there.
Why not?
Can't. It doesn't work. You also can't take the log or natural log of a negative number. It all has to do with the domain and range restrictions of exponential versus logarithmic. Okay. All right. Let's pick one more. Let's look at 12. How would you write 12? Okay. So what does that mean? Yep. All right. So you're fine with those? Yes. Okay. Down below here, it's the same idea. It's just not written as an equation. So you're just thinking through on the first one. 4 to what power is 64? Yeah, so this is 3. So the second one, 3 to what power is 1 over 81? 5 to what power is 5 to the 6th? Good, don't overthink that one. Number 4, base isn't written, so it's 10. So 10 to what power is 1? 0, good. Okay. Good so far. Graph. All right, almost done, guys. So down at the bottom here, we're now going to solve some logarithmic equations. So let's look at number 1. Very similar to what we were doing. How would you rewrite it as an exponential equation? Yes, 3 squared equals 4x minus 7. So 9 equals 4x minus 7. We get 4. All right, number 2. How would we start?
X squared is 64.
So what do you think x is? Yeah, just 8. Okay. All right, guys, number 3 is different. What's different about this one? It's got e, yep, and it doesn't start with a log or natural log. It starts with the variable in the exponent. This is why we have log equations, so that we can actually solve when your variable is in the exponent. So 2 things you can do. You can just rewrite it as what a natural log equation would look like, or you can use natural log as an operator and take the natural log of both sides. I'm going to do that because I want to review a couple of properties with you. So I've got natural log of e to the 2x equals natural log of 5. Do you guys remember where that exponent can go when we're doing logs?
To the left side.
Yeah, like in front of the log or natural log? Yeah, so this is really 2x natural log of e equals natural log of 5. What is the natural log of e? Oh, I heard mumbles. Natural log of e? 1. Yes, that's one that you need to know because you're thinking e to what power is e? 1. Okay. So I really have 2x equals natural log of 5. There are a lot of different ways you can write your final answer. We could say x equals natural log of 5 all over 2. You could say x equals 1/2 natural log of 5. You could say x equals natural log of 5 to the 1/2. You could say x equals natural log of the square root of 5. All 4 of those are equivalent and correct. Just realize if it's a multiple choice question, I might give you one of those. So you should recognize all of them. Do those all make sense to you? You understand what's happening there? Okay. Questions on anything, guys? Let's do 4 real quick. It'll be our last one for today. So if I rewrite this in exponential form, I'd get 2 to the negative 3 equals 8 to the x. What do you want to do there?
8 to the negative 3 is 8 to the x.
So how about I make my bases match? So 2 to the negative 3rd equals 2 to the what?
3x.
3x. And then negative 3 equals 3x. X is negative 1. Okay. So a lot of this unit is being able to recognize when to do what, because there's all these different approaches to take when solving, and you just have to recognize when you need which approach. Okay? All right, we are not getting to this growth and decay part. That's fine. So let's look at your homework. I'm going to have you skip a couple. More than a couple, actually. So let's go ahead and skip 5, actually through 9. And guys, if you look at the back, I realize 10 through 19, there's like no room for you to do work on those, but you'll be okay. The rest of that is good. And notice, I'm not asking you to graph everything on here, like 2 through 4. I'm just saying describe the transformation. That doesn't mean you have to sketch the whole thing. You just have to tell me, like, write 2 up 5. Okay? Same thing on the back, 20 through 22. You're not actually graphing it. You're just telling me what's happening. So it's not as long as this looks to begin with. Okay? Questions on anything, guys? Okay. Take-home quiz is also due next time. Okay. Do 5 through 9. Yep. 5 and 6 are the half-life stuff we haven't talked about yet. And 7 through 9 I feel like are kind of trick questions, so I won't make you get tricked right now.
So.
Here, let me stop.